In this video, Hello everyone, welcome to Smart Learning. In this video, we will be discussing about the solution of this question. You are given n wires, each of resistance R ohm. What is the ratio of maximum to minimum resistance that can be obtained from these wires? On the screen, you can see one of the industrial resistor, and its resistance is 100 ohms. This question can also be specified as you are given 5 resistors, each of resistance 100 ohms. What is the ratio of maximum to minimum resistance that can be obtained from these resistors? We will find the ratio. Now let's start the solution. To understand the solution of this question, you need to have some idea about the combination of resistors, that is a series combination and parallel combination of resistors. We have made video on these two combinations. You can watch that video by clicking on that I button, or the links for you are provided in the description. You can check that. Let's start with the series combination in shortcut. So if we have two resistors, each of resistance R1 and R2, and their series combination is shown in the figure, and equivalent resistance of these two resistors in series is Rs is equal to R1 plus R2. For n resistors, each of resistance R, equivalent resistance is n times R. We call it equation number 1. And note that equivalent resistance in series combination is greater than the greatest resistance in the connection. So what does it mean? The detail of this concept you can get from the previous video of this channel. Please check it by clicking the link in the description. Let's go further. Similarly, for parallel combination of two resistors of resistance R1 and R2, the equivalent resistance Rp is equal to R1 times R2 divided by R1 plus R2, and the circuit diagram of series parallel combination of these two resistors is shown on the screen. And note that equivalent resistance in parallel combination is smaller than the smallest resistance in the connection. You can find the video link in the description for this also. You can check that after finishing this video as well. These two are the series and parallel combination of these two resistors. And for n resistors, each of resistance R connected in parallel combination, equivalent resistance is Rp is equal to R by n ohm, and we call it equation number 2. These two are the equation we will be considering for this solution. We get maximum resistance from series combination. I have discussed it in previous video, because in series combination it goes on adding resistance values, whereas in parallel combination we get minimum resistance, because product of resistance values is divided by their sum. So for n resistors, each of resistance R ohm, we have equivalence resistance in series combination is maximum. So R max is equal to n times R ohm. This is equation 1 as we have considered before. And in parallel combination of n resistors, each of resistance R ohm, equivalent resistance R minimum is equal to R by n ohm, and we call it equation number 2 as well. Now let's divide equation 1 by 2. Then we get the ratio as ratio is equal to R max by R min, which is equal to n times R ohm divided by R divided by n ohm. Further simplifying this expression, we get ratio is equal to n square. Thus, ratio of maximum to minimum resistance is n square. Remember that value of ratio does not depend on resistance values of given resistors. You can see here is absent of R. So only n square is there. That is, this ratio depends only on number of resistors. So n is the number of resistors, and this statement verifies the presence of n in this statement. Okay. By given example, we have 5 resistors, each of resistance 100 ohms, and we have to connect them in series as well as in parallel combination to get maximum and minimum resistance respectively. So here R is equal to 100 ohms and n is equal to 5. By applying the formula, R max is equal to n times 100 ohms and R min is equal to 100 by 5 ohms. And using these two values, the ratio becomes n square. 100 cancels 100, so we get n square, and substituting the value of n, we get square of 5 and it becomes 25. So required ratio is 25. So in this way you can solve the question like this, and this is one of the most important and most asked question in 12th standard board exam. You can practice it from this video as well as you can consider other examples too. Here I have given one example. Please try another one example. You can find questions in your books as well. Thank you for watching. For more videos, subscribe Smart Learning channel. Keep learning and stay connected with us. Thank you so much.